Hi everybody, you are listening to me in this video. This video I will show you how to make the surface cover the STL file or the point cloud. STL file is created from 3D scan. 3D scan is reverse engineering tools. Okay, let's get started. I just show you how to make the surface cover the STL file using the CATIA program. Okay, start up at the CATIA program. You open it, the CATIA program first, and going to create a new workspace for this file, for this work, right? Part, okay, click OK again. Okay, right now the default tools, the module in the CATIA program show up in left and right side on top, right? Part design. Okay, this is a part design. This video I focus on the reverse engineering. Right? You need to click on the workbench, switch to the digital shape editor, and find down the tools. Cloud point, right? It's cloud point. Import. Select on the import tool, import command, and bounce to the data file. Data file created from the STL file, right? Okay, we're going to reverse engineering, and okay, need deck, deck สมบูรณ์ click OK, right? apply. Okay, focus on click on the group option, click apply, click OK. Okay, check it out, the standard view. Okay, it's not matching the standard view font. Okay, it's font, right? And okay, just in normal view. Okay, leave it on your focus on, right? Your side, right? Your side focus on this picture, right? It's a picture in this screen. Okay, it's a correlate. It's a normal view, right? It's not problem, right? Okay, but maybe sometimes you need to adjust some standard view. Okay, then on your workpiece, right? Standard is not matching when you click on the front view, right? Okay, right in the top view. Okay, actually it show you in the top view. It's not front view. Front view in intuitively is most people have known about. Okay, this should be front view, right? Okay, this should be front view. Okay, how to adjust the workpiece, and the workpiece to match on the standard view. Front view will still be front view intuitively, right? Okay, I will show you how to adjust the axis, right? How to adjust the view of your workpiece. If you look at the axis system, okay, it's far away. Okay, I need to move your workpiece axis approach to the absolute axis system, right? I will use the compass. Okay, you drag the compass point to the bottom surface of the point cloud like this, and you click on the background. You need to make contrast individual and evidently with the point cloud, right? Okay, like this. And okay, still be point out at the z-axis, the w-axis of a compass. I need to switch up, right? Switch up to the standard view. The standard view mostly the z-axis point out, right? Okay, I will adjust, click on the compass, and I going to switch up of the W axis. Okay, W axis represented uh, with Z axis, and right the Z axis, right? Okay, I will readjust and find the angle, right? Switch down, switch to up, right? 180 degree, right? And I move, right? Click on this, move. Okay, switch up already, right? Switch up already. Okay, switch up by using the increment, right? Increment, right? 180 degree, switch up. And okay, the gray color of the contrast mean right now the contrast independently with the data with the point cloud, right? And you need to engage the contrast with engage to the data to the SCL file. Okay, you click on data is on the SCL file where right now my contrast engaged to the point cloud already, right? Okay, I will move my point cloud to zero origin, right? Is going to its origin with the absolute axis system. I apply a setup absolute, right? This is the absolute axis, absolute method to move method absolute coordinate system. It just fill in the 0 0 0 x y z already, and I apply. Okay, right now and the data move toward origin of the absolute axis system already, and okay, still okay, miss the orientation. And the orientation is standard, right? Okay, you forgot on x y z in the three axis system, right? Three axis of the absolute axis system, right? Okay, I just I just I just need to make the make the axis of the workpiece match and co-along with the axis system, right? Okay, I fill in the zero angle, 0 degree angle, and 0 0 0 x y z like this, and apply. Oh, I forgot engage. Okay, 0 0. Okay, this time my data, right? My data, okay, go along with the standard view of the absolute axis system already. I apply. I just test first. Okay, front view. Okay, not it's front view. I just turn and minus 90 degree. Engage together. Engage already. Apply again. Oh, sorry. Zero. Oh, okay. Turn around with the z-axis. Okay, z-axis. Front view. Okay, that's it. Okay, that's it. It's correct. Right. Okay, this front view. Top view. Okay. Makes sense, right? Top view still. Okay, look from top, right? Your eyesight look down to the head of Deck bone, right? Okay, it's correct. Right? Top view, front view, left view. Okay, this makes sense and match on the standard axis, standard view already. Okay, turn back to the front. Next step, I'm going to show you how to make the surface cover the data. This work, it doesn't be serious uh, for how smooth it is. It's different from the previous video. I taught you about how to create a surface cover the home bed home phone and handset home phone. That work is focused on how smooth it is. Right? You need to make the surface cover that work being smooth as much as possible. They're very seriously about surface, right? Okay, in that way, that method is different from this video. This video will focus on how to create a surface. It's easy to create a surface and use the new tool. I will teach you the new tool create a surface cover this data. Okay, still we create the surface, write the original surface. That's it. Right? I should create that. Okay, use the easier tool from than the previous video, right? Okay, that video create a bed, home phone, use many module, use a quick surface reconstruction, digital shape editor, generate shape design, and part design a lot, right? And this way, okay, very easy. I will show you. Okay, I bring you to know about a new tools, a new command. Okay. Okay, switch to quick surface, quick surface reconstruction. Okay, going to last one of the toolbar, surface creation. Click on the last one, automatic surface. Click on the data point, right? The data point. Okay, this one and deviation. Okay, the error permission, right? From original. I left the new surface should be 0.1. Okay, I try it. I try. And the element is a small element, right? The one pad connect to another pad, right? Another surface, right? Another surface connect to another surface. Okay, over again until the new surface cover all of the original data, right? How much and how many the small surface? How many the small surface? Okay, right? Generate the small surface, connect to another surface until the cover of the original. How many the surface you will use, right? You will create the surface matching the data point, matching and the cover the original, right? And the first time I just 10,000 small element to try. Okay, it's the wrong time, right? Okay, you got the surface, and you got the surface already. Okay, we show you the shape of the small element. I told you, right? Okay, you show up on the screen what the small element shape to connect together until the small surface all cover on original. Okay, you show you this is small surface connect together, right? And match on the data point like this. Okay, you can hide the data point, right? make sure the high. I need to hide the edge of the surface, the edge of the small surface. Look at this. Okay, you got it. If you accept, okay, you prefer in the surface, the surface and the CATIA tool generated for you. You prefer this and enough for the surface. Okay, you click the OK. Leave the command box, right? Like this. You got the surface, automatic surface. Okay, you click one command, you got the surface already. The surface, okay, you look at this. It still be smooth. It will be smooth, the finest surface, right? Okay, it's just enough for matching the data, matching the original, right? It's cover the original as well as possible using the small surface, right? The small surface connect to the another small surface, over again until you got on the surface, right? Nearly represented with the original, right? Okay, you got the surface. The next step, you should make that surface to be to be solid. Right? It's called solid because it's solid. It can be used for creating the G code and modify something in the solid model, right? Easier than the surface. Okay, when you create the solid from the surface, right? The solid mostly put in the data into the part body. That means I bring you to use the right button and your mouse click, right? Click on the part body and slide down to the define work object. Okay, next command should be put into the part body, right? Because next step I told you I will create a solid, right? From the surface, cold surface, transform to the solid, and that solid put into the part body. In the part body, right? Okay, this is the container. Keep some command, some feature, right? The solid model, right? Solid should be put into the part body, right? Okay, switch to the part body, the part design, and okay, to find out the command, the new command. Okay, command in the part body, the command in the part design. Click down to this. If you could not find out this command, you should focus on the main menu and focus at the insert, right? Insert and surface based feature and code surface. It's code surface, right? Just click on the surface, right? Yeah, automatic surface, and apply. Okay, you got the solid, right? Okay, right now you got the surface, the solid already. Let me hide the surface. Okay, you got the solid. Okay, you got the solid already. This data, you check it out. This data is not smooth at the bottom surface. The bottom surface has the roughness, very rough, the edge missing, missing how it's smooth is it, right? Missing the flat, right? The flat shape, the flat curve, flatten it, right? You should flatten the edge of the bottom surface, right? Bottom surface is right now is a miss the flat shape, right? Okay, you just modify some surface at the bottom, right? Let me move the contrast back to original position. This is original position of the compass, right? Okay, again you make you drag dot, right, to the right, right, the right the right button, right, right button, this drag from this from the previous position and let the contrast to the gray color and grab, right, use your mouse, grab at the red button, red point, right, move back to the right bottom, right bottom. It's a axis system, right, the axis, three axis from the standard, the CATIA axis. Okay, move to this and turn back the right top, right. Okay, we create the new pane. I need to split it off the rough edge. Rough edge, right? Rough edge is very rough, right? I use the split command and cut the rough edge. Okay, cut off the rough edge. Okay, that means how you use the split. The split need the cutting element and the object should be cut, right? Okay, two option, two parameter, and cutting need, right? The split command need. Okay, going to create the pane, right? Okay, the pane. Going down and okay, font, right? Font. It's font. Okay, look at this. Go up. Okay, it should be on this edge, right? This is rough edge. Okay, it should be on up to Z, right? Up to along with the Z axis. Okay, apply test. I will test first. Okay, going to the command split and select on the splitting element. I need to use the pane, right? And the angle, right? If we got on where is the your workpiece, you need to keep, right? Okay, you point on keep surface, keep solid. This side you need to keep, right? And okay, scroll up, point to what area you need to keep the surface. Okay, apply, and you got the smooth edge. Okay, little bit. I will double click the pane, right? Click up 1 millimeter. Up 1 millimeter. Okay. Okay, I got it. I got it smooth surface. Smooth bottom surface. On maybe sometime I need to create a dark surface, because dark surface depend on the gravity mode and core mode. Okay, easy to move out when you create the part inside of the mold, and you need to take it off, right, from the mold. Okay, easier if you generate the dark surface, and it's not angle shape, the 90-degree shape, right? You need to create the dark surface, right, the angle. Okay, it's the angle. draft angle. Okay, the draft angle for creating the mold, right? Okay, like this. Okay, when you use the cutting tool, touch on the surface, right? The vertical, exact the vertical, right? And the tool have the sharp edge, sharp edge, sharp edge at the drilling and the drill, right? Drill tool have the sharp edge. You can use the sharp edge, right, for cutting the material out, right? Okay, the sharp edge is not on off the stick, right? Of the stick of the cutting tool, right? Just it's a this is zone, just only this zone for cutting the workpiece, right? This is the zone. This is zone have the sharp edge of the cutting tool, right? Sharp edge of the cutting tool. This is the sharp edge of the cutting tool. If your workpiece, okay, your workpiece vertical, right? Is the vertical direction, and the sharp edge not enough, and not enough for depth of the workpiece. This depth of the workpiece is deeper, and the cutting tool range, the sharp edge range is not enough of how deeper is your workpiece, right? How is your workpiece, and the cutting tool is not enough. It's not matching the how deep of your workpiece, right? Okay, it's not enough, right? Not enough, it means okay, maybe your workpiece, the cutting tool is fail and it's broken, right? Because you never have the cutting tool some area of your workpiece, because your workpiece deeper than the range of the workpiece, right? The range of no, the range of the sharp edge of the cutting tool. It's not enough, right? Not enough, and it cause to do cutting tool is broken, right? Okay, maybe you can avoid that problem, right? If you make in the sharp edge, right? If you make the sharp edge, hey, no, it's not. It's protect the sharp edge. It fail. Sharp edge of the cutting tool to fail. You should be creating the the draft angle of your workpiece, right? Okay, I will create. I will create the angle of draft, right? The of draft. I will use the pen, right? This is a pen. The cutting tool, okay, is a flat surface you got, and I will preparing when you need to create the draft shape at the bottom, right? At the bottom, because when you create the cutting mold, cavity mold and core mold, right? Okay, maybe the bottom co-align with the vertical, right? The co-align with the vertical. Maybe the range of the sharp edge, the cutting tool, okay, you cannot cover, the sharp is not cover the material and your workpiece depth, right? Yeah. Okay, I protect that. And you preparing the pen, preparing the pen, right? Okay, I will make the pen, the new pen, right? Click on this. I create a point, right? This is a point at the pen, right? The pen start at at center, right? Okay, I will need the center of the pen, right? Okay, I have a preview. Okay, I got the center point. Okay, I will create the angle. Reference, rotate, right? The rotation and the reference, the pen, right? In this angle, phi angle, right? It's phi angle. Create the pen. Click OK. I will okay, another pen, right? Another pen move parallel to point, right? Different this one and 2 point into this one, right? Okay, this angle, little bit angle 5 degree, little bit. Okay, I got the angle shape. I need to change to the new color. This color pen number 3. Okay, this one high. Okay, the split, double click on the split, right? And the pen change to 3, right? Okay, the file object. Okay, little bit angle. Insert body. You make the base part, make the base part. Insert new body to make the base part, right? Okay, I will bring you to create a sketch. The sketch this is the command. Create a sketch and reference. It's a reference. I need to use this. Okay, V and H swap. Okay. Oh no. Oh, this orientation. Use this HV. Okay, it's correct. Okay. This one. This paper for creating the profile. You need a profile. Define the size and the width of the base part. Just press control, define symmetry line, symmetry line, and symmetry line. Okay, it's not exactly the middle between two lines, right? Okay, I don't need use this one. It's just my eyesight. Now for this, okay. Okay, I will use this model creating the cavity mold. That is a cavity mold. That means I will take the face of deck from bone, flip down to flip down. Oh, sorry, is it flip down? Here this side, okay, flip down. Okay, the first flip down to bottom, right? Okay, I will make the part, right? Okay, this part, this is the rectangular part. Click OK. Rectangular part. I remove from the part body. Oh, sorry. Okay. I can. I need to alternative and the part. I need to change the body to become to part body, and the part body put into the body too, right? Okay, interchange into part. Change the part body, right? Okay, yes. Change the, right now the box, rectangular box still be it's not rectangular box become stay inside of the part body, and the model become to part 1. This is part 1. Okay, I use the part 1, remove uh, the material from part body, right? Okay, like this. Okay, it's still if you look at this, how deep your workpiece, right? It's how deep your workpiece put into the rectangular box, right? How deep, and okay, the cutting tool must be deeper, than this, and okay, the length of the sharp edge of the cutting tool need beyond, right? Say beyond from the workpiece is a gravity mold, right? Otherwise, if shorter than this model, right? The depth of the workpiece, depth of the model, right? Depth of the model deeper than the length of the sharp edge of the cutting tool, right? Okay, the sharp edge it cannot enough for cutting on all the surface because this model deeper than the range of the sharp edge of the cutting tools, right? Okay, that means why need to create the angle, right? I call that the dark angle. Okay, you see dark angle. Okay, dark angle. I will try. Okay, this one. Okay, this may be in another side, right? Okay. Okay, this side is better. Okay, I just over over. Okay, yeah, you clearly to look at how different. Okay, the vertical line and the dark angle line. Okay, how it's different. Okay, clearly that means let me use it more than over the value first. Okay, and okay, you clearly understand. Okay, we back to small angle and maybe 5 degree apply. Okay, you see it's not vertical anymore. It's not vertical anymore. That means okay, the corner of the cutting tool, just this corner, it's not on off the area, it's not the area of the cutting tool, or the edge, the sharp edge of the cutting tool. It's not on off the area, right? And just cut the workpiece, just the corner, right? Is touch just the point, the corner, the point, right? The corner of the cutting tool touch together with the surface of the cutting tool, the surface of the workpiece, just the point touch. The point touching is not the area touching. The cutting tool touch the workpiece, just the area. Okay, you make a lot of the force, right? Of the cutting tool force to the workpiece. Okay, a lot is force, right? It maybe the cutting tool is broken easier. Right? Okay, you avoid that by using the dark angle. Like this. It's over shape, right? Oversight, and mean okay. Let me turn back. It's turn back to 5 degrees. Enough. Little bit, okay. Little bit is the dark, right? Not different too much from the original, right? The original is just vertical, and this okay, just 3 degrees, because you just avoid the touch area, right? Touch area maybe the cutting edge. The cutting edge is the not enough for depth of the workpiece, right? And you avoid that way. And okay, use the dark angle. The cutting tool touch right, the point touch, right? Okay, you can avoid and the front too much, right? Okay, just use 3. Okay, yeah. Okay, yeah, just look at the vertical, still vertical, right? Okay, you got the workpiece, you got the cavity mold already. Okay, bring you to the CNC. You go into the main menu, look down and scroll down to the machining and surface machining. Okay, this is surface machining, and I need you to set up some option at the options in the CATIA program, in the main menu tools, to slide down to the options, to option, and scroll down, focus on machining. It's a machining, right? You got the machining. This is machining. Okay, you go into the tab output. The tab output, I need you select on option number 3. This option IMS. This is the post processor. The post processor used for which convert the two part, right? The two part, convert the two part to PG code. Convert the two part to PG codes using IMS library. This is IMS library, ICAM library, right? And CNIT library. Okay, I need you set the IMS, right? Because the processor you for transform to the T code, right? Transform the two part to the G code. Lead it on the controller. The controller is control the axis, control the mechanism of the CNC machine. Right? Control the CNC machine. Use the controller. The controller, a lot of the brand, right? All the brand is control the CNC brand of the world a lot, right? Okay, use the controller. The controller have known about the G code, right? You must know about G code, and the G code convert from the two part using the post processor. The post processor try to convert G code matching with the controller. Because the controller axis, the controller mechanism of the CNC machine, right? That means it's very important, right? Important. And okay, I have known about IMS library. There is the controller is matching with the mini CNC in our lab, right? It's our laboratory, right? Okay, it's matching. That means why need use the IMS option. IMS option have the processor transform the two part to be the G code, and that G code matching the controller of the mini CNC, right? In our lab, right? That mini CNC stay in our lab, right? Our laboratory. Okay, use IMS and the output, right? Okay, this attention. Normally, the CATIA generate the CAT NC code, right? NC code like this. That means okay, this CATIA generated for you, right? And for us, for the machine in the laboratory, mini CNC in the laboratory need the file attention is NC, right? This is NC. Okay, you can change, right? Because whatever you use, you set up NC and still be CAT NC code, no problem. Because use the program Notepad can be open. It can be open. Notepad can be open. CAT NC code or the NC, but the NC, if you save in the CAT NC code, right? Maybe CAT NC code, and okay, you upload as CAT NC code extension to the mini CNC machine. In that machine have the computer control the CNC, right? Control the CNC already, and you put in and upload CAT NC code to that computer, right? To that computer, and you have to change the extension to be NC code that time. If you lazy and maybe you forget in that time and change to the NC later, that means okay, you can protect, you can avoid in that time you forget it. You forget to change to the NC name, NC attention. Okay, I suggest you should set up NC, right, in the attention. Click OK, and also general, to the general tab. General tab, you click on this create a CAD path to store geometry. Click this option. Right? Then another one, you should follow me, set up some special option in this module, machining, right? General, click on create a CAD path to store geometry, and output, click on this IMS library and NC, right? And change the NC. Click OK. Click OK. This. Okay. I close it first because you just set up the option, right? Okay. You close it because that file, NC file, not yet in that sense open, not yet is set up the special option, right? And you click and set up the option later. You open the file, right? Okay, I suggest you close first and set up and reopen again it's better. Okay, I will bring you to repeat the procedure. I bring you to the start menu, going to the machine and set up the surface machining. Okay, you got it. This is write the folder. This is the folder for raw material. This is the folder for part. So for part you created. It's created from the point cloud. Right. This is the part. Okay, it's waiting you create the raw material. It's waiting to create the raw material. Okay, I will set up the raw material. Okay, you need to find out this toolbar, geometry management. This is a toolbar. You will use this toolbar creating the raw material, because this is the target. This is your workpiece. Your workpiece. Before you got your workpiece like this, you have to machine, right? Remember machine to the raw material, right? The raw material is the fully material, not yet being cut, right? It's not yet being cut. And okay, you just emulate the real situation. Okay, you need to have the storage, right? It's a raw material. Okay, this program called stock, right? Create the stock. Okay, use geometry management. In the first command, create this. Click on this and click on your workpiece. This is the part, the finished part, right? And click OK. Okay, this is the surface. It's cover the whole, cover your shape, cavity mold, right? Okay, it's cover already. And that command, that surface stay on inside of this, right? This one, right? This part stay inside of the geometry set, right? Join, right? Okay. This option you click on this. General, you click on this. Oh, sorry, general. Click on create a CAD part to store geometry, right? Okay, this option you turn it on and that option, the program created this part for you. Okay, created this part for you. If you click on the create a CAD part to store geometry, and this part, before you use this command, right? Create the surface. Before this, okay, this write the container. Create this, write the container. Waiting you create the stock from this command. Okay, you got its joint surface already. Okay, next step, you double click on the part operation and define the machine you will use, creating the G code, right? Okay, the first command, you click on the machine, right? You select the first button. The first button is the 3-axis machine point 1. You click on this, click OK again, and the zero of your workpiece, your part, and you click on this. You set up the zero of your work, right? Of your work, and two part. The two part generate the two part. Generate the two part different with this axis. Okay, this axis, you need to define this axis, that is the reference of the two part. right? Reference of the G code, right? Okay, this is the start point, the 0 point. uh, okay, define the 0 point, click on center, right? And click on this edge. Okay, let me clear first again. Okay, cancel because it's the active. This is still active, right? Okay, I need to release the active command first. Okay, going to the part operation again. Again. Okay, again. 3 axis. Click center. Okay. Z. Okay, the Z axis. Okay, click on this and flip up X, Y, Z. Again. I set up Z. Right? Click on this edge. Z is point down, right? Okay, again. Point down. Okay, click on Z axis and lever, right? Click OK again. Apply. Okay. You need to set up the axis and this protect the G code, right? The G code, the coordinate of the G code, the point to point generate is the negative value. Okay, you need to protect because the y-axis point out, it should point out of the workpiece, and this zone y minus, right? Minus the y, right? When the y minus something because the cutting tool go along with this area. That means the point allow with area will be the negative, right? The negative. That means I need to avoid the negative value, right? Okay, I will set up again, right? And the x I define this x-axis, right? And lever x-axis, x, y, z. Click OK. Click OK again. X, Y, right? The right rule, your right hand rule, right? The right hand rule. X, Y, Z. Z is point up. Okay. This one, click the button. Define the part. Right? Define the part. This part. And another, define the stock. And the other, define the stock. Click on the joint surface. Geometry set number 1. Click OK. Okay, ready to use operation. Define the operation. Machine your part is cutting the material. The raw material is cutting by the machine, right? Okay, right now you're ready to set up the operation. Okay, click on operation number 1, laughing. Here the lap stop. This is the lap stop, right? The lap stop. Select on this geometry set and part. Click on the part body, and the offset on part is not Okay, this is the first step, right? And okay, cutting the raw material, cutting the material out, and it's offset from the target, from the workpiece and the finished part. Offset from the finished part is 1 millimeter. It's 1 millimeter. It's not the tool is not touched on uh, the workpiece, not on the finished part, right? Not yet, because it's the offset from the finished part, right? Okay, the next step should be reduced is the offset part, right? And until finish, the offset part should be zero. It should be zero, right? Okay, it start. Okay, test simulation. Okay, simulation. This is laughing. It's a laughing operation. The laughing operation. You can reduce the tools, right? Because the tool is the bigger. I think it's bigger. I use 6 diameter. Okay, 6 diameter you change inside. And okay, inside the picture, in the picture they show you on the command box. Right? Okay, I set up 6 diameter. I set up. Okay, I use diameter 6, and I will set up the tab number 1. This strategy, how you command the workpiece and draw and cutting on your workpiece, cutting on the raw material, right? This part, right? Okay, you define the part, the cutting part. Okay, this is the way how to define the cutting part. Leaded on the tab, right? This is the radial. Okay, you define the overlap ratio, right? If the overlap ratio, I show you if you okay, it's 80%, right? Overlap. What is the overlap? You click on the question behind of this channel. Okay, this overlap more, that means overlap is more, and the part, okay, the part, okay, and the part of the cutting tool is smaller, right? It's smaller. The part number 1, the part number 2, very close, when the overlap ratio is more, right? Okay, far away, the overlap is far away. Okay, it's widely, it's widely, and the space of the part, right? The cutting part is shorter, right? Shorter. Okay, I will show you. Okay, I define the 80%. Apply. Right? It's shorter. Okay, it's smaller. Right? The part number 1 and part number 2 is space of the part 2 part, right? It's smaller. If you increase more the overlap percent, right? Okay, the overlap percent. You see again. This is the option. Another option, define directly to length, right? The length. And the part number 1 to part number 2, how many spread? How many spread? It's shorter, man. It's shorter mean okay. The detail and the cutting tool part, okay, very small. It means okay to make your workpiece smoother, right? It's smoother, right? Okay, it's fire and the finer, right? Something like this. Okay, this step over. Step over is opposite. Step over. Okay, less the percent. It's a less percent. It's okay. It's test 80%. 90%. Okay. If I set up 80%, what happened? What happened to your cutting part? It's your cutting part. Okay. Very, very big, right? It's very big. It's a more space. Part two part is just more distance, more distance, right? And the gap is part two part very big, right? Okay, in the opposite in the opposite direction, in the overlap ratio is more percent, and you will get this shorter, the part two part really short, right? And if step over, when you increase the percent more, and the percent more, and there's the part two part, it's a bigger, right? It's a gap more, it's gap more, and the part is the part is far away together, part two part, right? Okay, you need to reduce if you use the step over ratio. Okay, you got smaller, right? It's smaller. It's spread very close. It's very close. Okay, every 10%. Use the step over. It's 10. Okay, it's smaller, shorter, and it's shorter. It's shorter. It's spread. Part two part very short. Okay, you got it. Enough for this. Axial mean depth of cut. How much depth of cut you will set up along with the z-axis? How much? Okay, right now this is the default 10 and 5 millimeter. If you reduce the space, the one cut depth, use 5 millimeter. If I use 2 millimeter, right? Okay, the 2 millimeter, you see the step. Okay, it's more step. This program generated for you, right? It's a more step because very close, and level 1 to level 2, right? It's a level 2 level culture. It's culture, right? It's culture. Depend on this option. Okay, 1 millimeter. It's culture. You see, it's the wrong time to compute. That's a millimeter, right? Okay. Click OK. Now you set up already. Okay, this is the part, two part style. This is the whole scroll, and maybe you set up other strategy. Okay, right now use the whole helical. Okay, click on this. It's laughing, right? Laughing. It's not yet set up the finishing, right? This just is laughing. Okay, you set up next step to be finishing or semi-finish or the finish. right? Okay, depend on the offset distance. Either offset distance you set up to 0 millimeter, and that means you're going to make finishing, right? And if you are still 0.5 left, okay, that means you are going to do semi finish, depend on the offset. Okay, you see, this is the last cut. Click OK. Click OK. Click OK. You accept. You accept this procedure. Okay, and this program stay inside of the part and the tree diagram inside of the manufacturing program one uh, is laughing, right? It's laughing. And next step. Right now, the stock is gone, right? And still have some material. It's been cut, right? It's been cut in the material, some part out, right? Okay, you can hide. You can hide the stock out. Okay, I will set up sweeping press to uh, sweeping. You need to keep sweeping operation under, right, behind of the laughing operation. Click on this sweeping. Okay, go to behind of the laughing, right? Click part, select the part, click this. Okay, use 3 millimeter, 3 millimeter. Adjust the tool, 3 millimeter. If that machine can be adjusted, it can be adjusted. You can be change the tool automatically. You can set up different the tool in the one process. Change the tool in one process. And if some machine you cannot change automatically, it's not to change automatically. You cannot set up the machine to change the tool automatically in the G code, right? You use the one diameter of the cutting tool, right? Use is one program. If you need to change, you create another one program, right? Okay, and speed up to program, because you could not change the tool. The machine cannot change the tool automatically, and this is one tool should be used for that machine. The machine is not interchange the tool automatically. You must use uh, only 2 diameter for one program, right? Okay, right now I assume it can be changed, right, automatically to change 3. Oh, sorry. Okay, this 5. Tab number 1, strategy. Its strategy is radian, right? Radian, you use constant. I need to use 1 millimeter, right? Part to part, right? Have the distance part to part 1 millimeter. This one, click OK. And going to the tab number 2, right now still be 1 millimeter. Let me offset on the part. Let me use 0, right? Okay, 0. Okay, is 0, and these two cut on the top of top surface of the workpiece. If you need to avoid this surface uh, being cutting by the tools, right? Because you need to keep transparent, because maybe the material used acrylic. This is acrylic. Okay, the on top, if on top surface being cutting by the tool, okay, the transparent shape, transparent surface is gone, right? It's not it's not beautiful. Maybe you need to keep, right, the transparency, right? Transparency color, right? Okay, that means you have to avoid and set up the cutting tool should not be should not be should not be cutting on the top surface, right? Okay, how to set up to avoid that area. Okay, I'm going to click on check this check check click on top surface, click OK. Okay, check already again. Okay, just inside, right? Okay, reduce speed, add the speed up, yeah, using the slide bar. Okay, still be running for laughing. Okay, still be laughing. So running in the two part of the laughing operation, right? In the laughing operation, you take the time. The machine. Okay, done. That's it. That's it. If maybe you not prefer this operation because it not uh, it still be laugh, right? Still be laugh the surface. You need to go on about setting the thumb operation more. Right? Okay, you click on this thumb operation more. Axial, right? It's axial, maybe it's running a step, two level, and the level is 0.5, right? Okay, it's a fineness. It's fineness. Do hope it's fineness. And okay, radius is still be 0.5. Right? What is the scallop height? Okay, you use the question. It's called scallop height. The cutting tool move part, right? The one part to another part, right? Another part, and okay, between the radius, two radius, still have the remainder. remainder material, okay, at between two parts, right? The height of the remainder material, I call that scallop height, right? If scallop height you keep down, you keep, okay, reduce the scallop height. That means okay, if the last surface you hold is gone, if scallop height is very small, right? Okay, I hope that the machine, right, is this use the zigzag. What is the zigzag, right? Okay, move left to right, right to left, left to right, right to left, right, depend on the picture. It's not the cutting to doesn't move up along the left, right to left and return to right again. Okay, doesn't less up the cutting tool, right? Okay, call that zigzag, right? It's called that zigzag. Okay, generate again. Okay, zigzag and radius 0.1. Okay, I need to force it. It's the maximum part to part. Use the space 0.5. Okay, 0.5. Okay, this one. Click OK. Click OK first. Click OK first. I forgot save. Okay, I need you. I bring you to how to save your work, right? In the G code in the process machine surface machining module. How to save? Okay, I bring you to is a file, menu file, go down to the save management, and this the command block show you how many the file you should save in your computer. And the first one part, right, is part. 2 the process file. 3 the container, right, the part of the raw stock. This is a part of the part, right? So the stock of the stock, right? Okay, all of these should be saved. Okay, going to the process, cat process, right? You click save as. I'm going to this page, right? Okay, you define this folder to be the storage, for this file. Okay, and if not, you might be setting the new folder, right? New folder is the cam. Okay, click on this. Maybe it's cam for deck chụp. Okay, double click inside and save. Okay, we save this. Save the main part, the main file extension cat process. You click on the propagation and on off part. Okay, should be saved the same folder, right? The same folder. Click OK. Okay, done. Turn back to the operation process again. Double click in sweeping. Right, click sweeping. Okay, you got it already. I click on this again. Okay. Let me turn back to this stock. Let me clear recess and click again. Stock. Okay. Click stop. Okay. Again. Turn back to I need to show up. Sweeping kick, right? Okay, this is show up the stock, right? Okay, avoid the message pop up. No stock defined. Okay, you put you show up on stock, right? Okay. Okay, click. Take time because I set fineness parameter. There is fineness parameter. Okay, a lot of the step of depth and the part two part very close. Okay, take a long time. Take a time. It still be laughing operation, not just opposed to the sweeping, right? It still be laughing. If okay, right now opposed to the sweeping, right? Sweeping, okay, is the finest, finer than it's better than the previous time, right? And two level number two, right? Is level number two. Okay, good. Right. Okay, maybe sometime uh, you would like to create another direction, right? This direction across along with the y-axis, right? And maybe you need to cross the x-axis, right? Okay, this operation accept, and I copy one, copy and press over here. Okay, you got another sweeping operation. Right? I lazy to set up and tool and the part and stock, right? I bring you to shortcut copy and some parameter I need to change, right? And accordingly not at all. I just change little bit step, right? Okay, double click on the sweeping. I need to modify some parameter from the sweeping tool. Right? Okay, click on this. Okay, I will set up, right? Set up the area. I click on this because everything done, right? I already set up at the sweeping one already, and this okay, check this. Okay, you see it. I will interchange the direction. Okay, I set up this. I will select on this one, right? And this is M. Okay, switch to cross of the workpiece, right? Okay, try. Click on this. Generate key. Right? You see. Okay, go to along with the x-axis, right? It's already the axis, right? It's cross together. It's week number one in one direction. The week number two is across another direction, right? Okay, it's right across together to two part. Okay, I will click on this. test. Take a long time because very finest two parts, right? Okay, is going to direction y-axis, right? It's sweeping one, sweeping two, right? Did the level number two or the sweeping number one, right? Because I set up two level, right? I split the one cut depth bit two bit switch to the two level, right? And the two step. This time. Okay. Why you never have to cutting material off, right? Because the sweeping one I set up the 0 mm offset part distance already, right? Okay, never have some material. Okay, you see, right? Okay, right, the cost. Okay, I think it's done in this step, right? Okay, click on this, you done about the operation. And okay, this time we need to convert, right? Use the processor convert to the G code, right? These two part for traffic, two part for sweeping one, two part for sweeping two. All of these transform to the G code using the processor. We already set up in the library IMS library, user library, IMS library. Inside of IMS library, there were the controller band, a lot. I will show you. Okay, click on this. Show you how to transform and convert to the G codes. Right, you click right button and point at the manufacturing process. Sorry, manufacturing program, right? Go down the last one, command, and click on generative NC code interactively. Click on this. Okay, you got the command and go in tab number 4, tab for NC code, right? Okay, the IMS processor. Okay, click on down list, the dot list, right? Going to the FANUC controller brand, right? Okay, and series FANUC E11M, right? E11M. Okay, E11M. Okay, the right, the controller brand. The controller is control the CNC, right? The CNC uses this brand, the FANUC E11M, right? Okay, going to tab number 1 and select on resulting NC data. Click the NC code, right? And the output file. Where do you need to keep the output file to, right? Okay, you have to click on the 3 point, right? 3 point is browse to the storage. You would like to keep this file. Okay, I already set up, right? Set up already. Set up already the folder. You keep on the file depend on the CAM mean computer aid manufacturing. This folder. Here time I set the folder in the menu file save management, right? I already set up the folder inside of this folder to 215 revert. Okay, revert and deck chụp, right? This is NC code. Save and press execute. Click on this and continue. Okay, success. When interactive NC output generation successfully end, right? Okay, click OK, click close. Okay, going to your storage. You kept that file already, right? You go to the storage, right? Let me going to enter that folder. Show you what the G code is. Okay, 2.5 and revert engineering deck chụp. Okay, this you got this file already, and double click. If you open first time, right? Open it for first time. You open with, right? Open with Notepad. Right? Don't forget this step. Okay. For me, I already open sometime before, right? I can double click on my file, G code file, right? Okay, you see this the line. This is the x, y, z is the coordinate, right? You have to move. G1 mean move to point to point. What is what meaning of the G0? What meaning is the G043, right? Something like this. You can learn what the G code is. You can learn by yourself, right? You going to the internet and okay, you typing G code, right? รหัส G something รหัส G. Okay, maybe G code. Okay, going to this, and you can learn the G code. What is G code? Something code command some. Okay, what is mean? G0, G0, G1, G00, G1, G16, G17, G43 something กำหนดความยาวของมีดกัดที่มีค่าบวกนี่ right? Okay, define the length of the tools, right? Length of the tools, the cutting tool. Okay, G90, right? Okay, you can find out the meaning, G code meaning, and you compare with your G code, right? You got from the CAM program, the CATIA program. You generated by using the surface machining module. You got this. Okay, a lot of line. You got it. 33,771 line. A lot. Right? You could not typing in the CNC panel line by line because very hard. Line by line is take a long time. Okay, you generated by the program. If okay, if you need to create the part and the part using the CNC machine, mostly use the CAM program. The CATIA program have the module surface machining, generate generate the CAD model, create maybe if you need to create the mold, you have to create the base part. If maybe sometime you don't need to create the cavity A, create the mold, right? You can use the CAD the CAD model, right? Generate the code, decode, right? And don't forget how to capture, how to grabbing your workpiece. Stay at uh, stay at the machine, the milling machine, right? In the bed of the milling machine, right? How to press your workpiece to the bed of the CNC machine. How to grab your workpiece, right? Grab the workpiece and you how to avoid the cutting tool cut on the CNC table, right? You have to think about the fixture, thick fixture, how to grab the workpiece, right? Strong at the table or the machine. Okay, think about this. This is another class teach you. I don't know. I have another course to teach you this the way, right? And okay, I think you have learned everything from the manufacturing process, right? Already. Right? Manufacturing process course. Okay, this time you have known about how to create the model, how to use the model for creating the mold. This is a cavity mold, right? Maybe sometime when you need to create the claw mold. Okay, save again, modify, save. Again, it's save. Okay, let me hide this. Okay, this is called the cavity, right? Okay, this part. Okay, this is cavity. If sometimes you need to create a core mold, right? Okay, I just save as. Okay, save as core core. Okay, core. Let me okay, remove, delete, and don't forget tick off, tick OK, tick off the some option. Okay, this the block, right? Okay, the block. Okay, don't work. Okay, you see this, and this area, because this area could not, I think it, and the cutting tool cannot approach to this area because it's a right undercut, uh, because and the cutting to go around is three axis. Three axis means vertical. It could not, it cannot move around with the y-axis, around with the x-axis, and still be straight co-align with the z-axis. On way co-align with the z-axis. That means the cutting tool cannot approach this area, right? It cannot this area. Okay, this area cannot. The cutting tool just is the vertical. It's a vertical. And go in this area, still have the material, right, from the raw material. It cannot cutting this area. It's what we call undercutting. Right, okay. This one, right? Okay, this and is darting. It's a dark angle. You already have the dark angle already, right? And the cutting tool, they approach to this and touch the end of the cutting tool. Touch is the level to level. Is the touch point at the corner of the cutting tool, right? Level to level, right? Okay. This is the core, right? Okay, save. I will show you again. Surface. This double click on the path 3 axis, click OK, and oh, I'm sorry, I forgot created the stock, right? Okay, stock. Okay, I forgot. Okay, I forgot add up. Add to the part body. Okay, okay. Right now it's unite together. We come to the one part, inside of part body. Okay, going to the machine, the surface machining. Okay, surface machining, and stop. Okay, you stop. Click OK. Double click 3 machine. Point. Click the origin and define the origin. Okay. X, right? Okay, click Z axis, define Z axis, switch up, right? Switch up. I'm seeing again. Okay, right. I'll see. Okay, not change. Again. Point C x-axis in this direction. Should be say in this direction is the x-axis, right? Okay. Click OK. Click OK. Oh, why not change? Okay, y-axis, x, y, z, z, x, y, z. Okay, click OK again. X, Y, Z. Done. Okay, click part and select on the part. Okay, this the part of the raw material inside of geometry set join 1, and this part of your workpiece finished part. This is the finished part, right? Okay, click the stock, right? Maybe you click on your model, right? The stock model. Click OK. Okay, and ready to create the operation laughing. Click in the program 1 and click in the laugh stock, right? Click on the part. Okay, and click on the part again. Okay, and okay, use 6, oh sorry, 6, right? Enter and define 6 diameter, 6 diameter. Okay, this is 6 diameter. If okay, this is the radius of the corner. It's a ball mill. It's a ball end mill, right? And maybe sometimes you use the flat end mill, you need to click off this one and reduce to 0, right? Okay, it's a flat end mill something. It's a flat end mill. And use for uh, fatten, fatten, fatten. The surface, the flat surface, and your object in your workpiece need the flattened surface, right? Okay, you have to use it. Have to use the flat end mill, and this time I use the radius, right? And the ball end mill, right? 6 millimeter. Okay, I accept this. Okay, and this one radius overlap, right? 80, 90. Axial 2 millimeter, 1 millimeter. You should save for generate the code, generate the two part, right? Maybe your computer is got stuck some process, right? Okay, and terminate the program by itself, right? You protect yourself, avoid that. Uh, oh, sorry, give me a lot of two part very small. Okay, it take a long time. Let me adjust some step. Okay, 1 millimeter. I avoid some situations got problem, right? Okay, protect you save everything first and click play the two part, right? Generate for you. Okay, you're really small. It's millimeter. Take your time. Okay, try. Okay, try. It take a lot of the time, right? Okay, so So in this step, you see, before I simulated in the two part and generate the G code, right? There is two part like this. I told you before, and this shape it could not, right? It could not quite quite undercut the surface, right? And still be straight, and still be the shape is a vertical, right? Because the tool cannot move along its y-axis, right? And the cutting tools go along on way press on the z-axis, go around the z-axis. It's only this direction could not change the orientation of the tool, cutting tool, right? That means why this area could not generate this curve in the curve under under this shape, right? Under is the vertical, and it still be go straight on the vertical line, right? Something like this. You got this, and you be careful. You are careful. You are careful about your cutting tool. In the real situation, the cutting tool is higher than the height, either than the higher of the height of the workpiece, because the height of the workpiece generate like the depth of the workpiece, right? The width of the workpiece, right? The should be lower than uh, the length of the cutting tool. This is the sharp edge length of the cutting tool. It's higher than height of the workpiece, right? Something like this. Otherwise, uh, the length of the sharp edge of the cutting tool could not cut the material out because it never have the sharp edge enough for the height of the workpiece, right? You careful when in the real situation. You careful and concerned about this, right? Okay, and this time the sharp edge of the cutting tool the higher than the height of the workpiece. The height of the workpiece, okay, in this area, okay, this one approach to this area for cutting, for cutting. It's cutting this area, the height of this zone is over here, right? And it's over here, right? It's over here. You can height the cutting tool. Okay, the cutting tool higher than this area. Okay, it should be cutting. It can be cutting. It can be cutting this area. Okay, right? It makes sense. Okay, go on. Okay, it's done. I click OK. You accept this step. Okay, the sweeping. Okay, this and change the tool. Change the tool 3 millimeter. Enter. Right, double click on this 3 millimeter. And okay, match to the end is smaller, and the base of the tool should be smaller too. 10 millimeter. Okay, and back to the geometry and define the geometry part, right? Part body and the offset on part to 0, right? 0 millimeter. Don't forget offset on part to 0 millimeter. Sweeping radius, right? Radius 0.05. Okay, 0.5 axial, one level, two level, take a long time. If you set up more level, it's more time to use, right? Okay, 0.1 tolerance, radius, use constant, เจอปรับให้ 0.1 โอ้ finest surface you hope okay take a long time right okay click on this start at thin swapping operation to a sweeping operation take a long time I click on that. Okay, I will script some step for you. After this process done, okay, you got this. Okay, this result from the swapping and the sweeping. Right? Okay, you see if the length of the cutting tool sharp edge not enough uh, for the height of the model, right, in this area, and okay, if you created the damping, right, angle is the damping angle. Okay, damping angle, okay, it can be speed up and range, right? Okay, the cutting tool touch on this and touch on this, touch on it. It's not touch on of the sharp edge into one time, right? Touch at the end, at the corner, at the end of the cutting sharp edge, right? Okay, to protect on of this, and maybe some the area of the sharp edge is not enough for the depth of the model, right? Okay, and this area never have the shape under this area. Okay, I'll show you this one core. Okay, this area, right? This area. Okay, the real process, it could not, right? It could not approach to the under area of the surface, right? The under area of the surface could not. And okay, if you need the serious here is this area, you need to use 5-axis CNC machine. A 5-axis CNC machine, right, can rotate your workpiece around with this one. If I compare with this, right, and okay, I will, because I switch the axis, I create a new axis because I create a new orientation in the module surface machining module. I define the 0 point, 0 origin, the new origin, and orientation is the new orientation. And this is the workpiece z-axis point to right your hand, and in the surface machining in the cam module, right, I sweep up z-axis point up, right? Okay, in the necessity you need to point up the z-axis in the surface machining module, right? Okay, the module. And if I reference this axis, okay, it's different axis, and the 5-axis, it can be moved around the z-axis in over here around, right? And okay, and right, flip up this area, flip up to top view, right? And okay, and cutting tools can be moving around the area if the table of the 5-axis CNC machine move, right, to rotate and bring this area up, right, bring area up, and the cutting tool can be moving, cutting around that area. This is the benefit of the 5-axis CNC machine. Right? Undercut can be cutting, right? Five axis, CNC 5-axis. Okay, you can find out and look at that the machine is right. Okay, you can so you put in the keyword 5 5 sorry 5 axis 5-axis CNC machine. Okay, you see this one. Okay, why a table, right? Is rotate, right? Okay, okay, you got okay, rotate table or the rotate the tools, no problem, and special you rotate around with y and x axis also, right? Okay, you see this. The 5-axis can be moved, right? You look at this. Okay, the table move around with the x-axis, move around with the y-axis, right? Okay, you see, the table is move and undercut area. Okay, the flip up and around the cutting tool move around with the flat surface, because if the three axis machine it cannot move the table around with the y-axis and x-axis, right? And 5-axis it can be moving. It means okay, the undercut area 5-axis will move up and the cutting tool cut around that area, right? Okay, this is the limitation of the 3-axis machine, right? Okay, you can surf internet and look at the video or a lot of the video. You use the keyword CNC machine, 5-axis machine, 3D scanner, everything, right? Okay, you got the knowledge in the YouTube. Okay, turn back. Okay, you got it. You got it. You got it, right? Okay, you're going to click on this, right? Generate G code, right? And in C code, look at the name file name file with the name, right? Okay, input output, NC code to bounce to your storage. Okay, you set up in your storage, and that storage you to keep your word, right? Okay, deck chụp NC code, right? And this is cam, right? It's a core. Okay, this one. NC, click OK and execute. Click continuous. Waiting. Pop up. Okay. And the message successful. Okay, click OK and close, right? Don't forget save management in this core, right? Okay, I will close previous. This is the cross. It's two course and save. One cross. Save. Okay. This one management again. It's save. Cat. Process, right? We process. Save as and core. It's core. We process for core. Oh. Save and propagate. Okay, click OK. Okay, in this video I think enough for this detail, right? And how to I taught you how to create the surface cover, the point cloud, right? And how to after you got the point the surface and solid, use the code surface command in the path design command, make the closed surface to be closed solid, right? It's one solid model, and use the one into that part, right? Use that part, making it a mold. It's a cavity mold and cold mold, and how to use combine in the CATIA program, create a base part, and use the surface machining module, create the T code, right? In this video, everything I taught you already. I hope you have the knowledge in this time, right? After you look at this video until now, right? Thank you for listening.